Hello all and welcome to Octave with Spice. So now we are on chapter 3 working with M files and the section function M files. So what's different between functions and scripts and what's the point in functions? So let us recall that we are looking at calculating a net present value. So that was the equation 3.1 here, as you can see, and we have already shown how to calculate this in script files, and there is a data section where you can change the data, and then the script file should work just fine with the different data also. And yep, this is one way of doing it, and probably one of the best ways. But let's suppose we have the following situation. So we want to calculate the net present value for many different values, I mean different cash flows, different interest rates, or we want to use calculate simply the net present value for many times. So then it actually makes sense to have a function called NPV that just takes these arguments and calculates them. And how do we do this? So, well, we define NPV as a function in a function file. And the difference of function and script files, technical difference, is that the function file starts with the keyword function. That's basically the only difference. They are both text files. But of course the working will then be different. So if the M file starts with the keyword function, then the GNU Octave will actually know that this is a function file and should not try to parse it as a script file. Parsing means that try to execute it line after line as it were in a command window. So this is not how you should use function M files. So instead, GNU Octave will only parse it or try to understand what happens there once it is called with arguments. So then it will pass these arguments as variables there, and then it should work as a function. Okay. So let's see an example. So this is the NPV that we had, but now as a function file. So the code is here, so you can download it here. Let's do this as it should be done. So let us save the file. Okay, and then let us move the file so that Octave will find it. So in my system it goes to the directory down. So here it is npv.m. Note the name. The name of the file should be the same as the name of the function with the extension .m. Okay, then I should move this to actually I have a shortcut here. So this homework teaching spicy or will be my Octave working directory. You'll probably have something different. In any case, choose the one that you have and copy it there. Again, here it says that it already exists. Should I overwrite it? Actually, I skip it now. And then let's open Octave. And let's here look at, we should have the current directory correct one here. Now it's not the correct one. Here I can change it. So for me it's work, teaching and spicy OR. Here. Now it's correct, and we can actually, if you have this window open, you have the list of the contents of the directory or folder. And let me just check it that it's there. npv.m it is actually. So let's open it in an editor. So I go to the editor tab here and I open npv.m just to see what's there. Okay, I again Control plus. The font is a bit bigger, so this file should be the same as contents here. All right. So what happens next? Here I'll just explain a little bit what I said before. So this, if it were a script file, we would call it simply given by its name. So let's try to do something wrong here. So npv, if I just type like this, there is an error. And the error is, it says that cf undefined near line 9, column 9, and again error call from npv at line 9, column 7. So okay, the error message, sometimes they are informative, sometimes they are not. Sometimes it's difficult to understand what's going on here. The reason is obviously that the Octave didn't understand, and it just showed that here I didn't understand something. So now we have to understand what Octave didn't understand. Well, what was the wrong? So something, it says line 9, column something. So here it actually, this is where it said that now something is wrong. Now I don't know what to do. And it says that cf is undefined. Okay, so here at the keyword function everything went well, but here it says that the cf is not defined. And well, as you can see, it's not defined here. And the reason is that that's the that's the argument of the function. We should give it to Octave. Octave cannot know it without us telling it. So the point here is that yes, this is not how you use a function file. Of course, you use a function file as giving the argument. So here is a conversation that works, for example, with console. So let's do this conversation with Octave. So what happens here? So now we have let's have a command window. Let's clear the window. Let's say r is 0.0. Let's use the same numbers. So this is 5%. Okay. And then the cash flow will be, let's see what I had here. For the 3 first periods, yes, or whatever, there is no cash flow. And in the 4th here, there is €1 coming to us. So now the cash flow and the interest rate are given. So now we should be able to call NPV with this cash flow and interest rate. I don't remember which way it goes. First cash flow, then interest rate, like this. And yes, it gives the answer. So that's that's how function M files work. Maybe a couple of things here that are actually not in the notes. I should point out that okay, I had to remember which way the cash flow and interest rate are given. So if I would call it like this, I get an error message, and the reason is that one is a vector and one is a scalar, and they are the other way around. And also the names that I use R and CF here that are the same names as here. They don't have to be the same name. So let's call cash equals, let's have a lot of periods that nothing comes, and then at the end of the period comes something. Let's put a semicolon so that it doesn't echo it back. And let us call interest rate the other one. Let's have a nice 10% interest rate. And then let's call net present value with this cash flow and interest rate. Okay, just names can be anything. Okay, why is the okay, not NVP but NPV, net present value. All right, and now it gives something like that. Also Of course, I can give these, they don't have to be variables, I can just give them. So let's have 3 periods, and after 1 period there is a €1, and let's have an interest rate 25%. Okay, it works like this also. So this is the, in a nutshell, how these function M files work, and yeah, the final exercise on this chapter 3, working with M files, is to modify this function npv.m, that is the function file that defines a net present value function, so that it assumes actually the interest rate is not constant. So the interest rate for the period t is something else than a fixed real number r, but can be different from time to time, as in the same way as the cash flow. And now this non-constant interest rate, it might look for it, okay, now this is much more complicated. Turns out it's not. It's yeah, a little bit of hint here. If you have to change this function a little bit, and the only change you have to do is in this line. This line what is here? Okay. And how do you do it? Well, now is a good time, I actually skipped it in the notes, is to explain how does this work from line to line. So what we have here, first, again, this is a comment block, as you note. It's Octave ignores it, except that there is a cool little thing. So we have already seen how to ask help. Let's see if we try to ask help of this net present value. Again, I don't know if my dyslexic or something, net present value this way. What happens is actually, well, it tells where it is. Now in this case it's not a built-in, it's my own function from this directory. Then this is the blah 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 stuff you always have in help file when you ask help. And then what is here is actually written down the first comment block here. Okay, so then comes something, this is empty line, Octave doesn't care about it, and then this is the first line Octave cares about, and it starts with a function. So this means that this is a function file. It defines a function called net present value. It will take 2 arguments that are called cf and r here, and it returns a value that I called v here. Okay, cf, r, and v, they are just some names. I could have used different names, of course. There is nothing magical about them. All right, then I need here sorry, then I need here the word end. So this end means that it ends this function block. So function starts here and ends here. What happens then next? So this is very similar to the what we had in the script file npv elegant. So the number of periods t is obtained from the cash flow vector cf by its length. Then there is a line that's actually not needed technically, but it's for many reasons it's good to have. So what happens next, that we will actually, this works slightly different in this respect than the npv elegant file. So there we had a for loop where the npv was incremented by new npv is the old npv plus the increment. Now we do this slightly differently, and actually this is less efficiently, but just for the fun of it, let's do it slightly differently. So the pv will be the vector of present values for all periods. So what happens actually here is that we will, the PVs for each t will be t summons. So we collect them all and then in the end sum them like this. So this works slightly differently than the NPV underscore elegant, but not much. And what happens, so I actually initialize this PV to be vector of zeros with length t and t rows and 1 column, or the other way around. And then what happens here in the for loop, so this for loop works the same way as this the NPV elegant, so t goes from 1 to t capital, and then this vector PV in its element t will be the cash flow at t divided by 1 plus r to the power t. So this here, these PV t's, is nothing but these summons here. So this for loop runs its course, so t capital times, and then this PV will be the vector of the present values, and what is the net present value is the sum of these present values. So surprisingly, if you have a vector, say PV, and I want to sum its all elements, it's just in Octave, it's the function sum. Sum takes the vector and it sums them. And v is then the value where the sum is stored. And now everything is done. Again, maybe I should note those who have programmed with, say, Java, or actually most programming languages, if you have a function, then you should have something like a return, blah, 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 to tell what the function is supposed to return. Here we don't have return statement. And the reason is that I have here said that the return will be v. It will return the v, and somewhere here, if we just define v what it is, that then the function will return it once everything is done. And here the v is defined here. So at this point, the function GNU Octave will see that there's nothing else to be done. Okay, everything stops, and then here, let's see, we have to return v. Do we know what v is? Yes, we have set v here, so v will be returned. And that's it. All right. That's pretty much all in this course that you should, at least at this point, know about how GNU Octave works as a calculator, how to work with M files, a little bit about matrices. So this was a general, I hope, a gentle introduction to Octave, and this is pretty much the first week of the operations research course, and the next week, the week number 2, will be about linear programming then with GNU Octave. So this is the spicy stuff. See you in the next lecture. Bye.